in the fetch execute cycle, what is going on? PC stores the address of next instruction. From PC, this address is transferred to MAR, and then from address of MAR, the data is transferred to MDR. From MDR, is data is sent to CIR, and CIR decodes it, and PC is incremented by 1. Now, the next instruction is 1. This is instruction number 1. The next instruction, address of the next instruction is 1. PC will send this address to MAR, right? From this address, data will be transferred from MAR to MDR. Now, the data will be transferred to MDR. I'll load 5. From MDR, this will be sent to CIR to be decoded. Now, CIR will decode this instruction. PC will be incremented by 1, so PC will become 2. And then the address part of this instructions means 5 will be transferred to MAR. It will go to the location number 5 and fetch the data from there into MDR. It will load it to MDR, and MDR will transfer this data to ACC, accumulator. Right? At location number 5, there is 12. 12 will be sent to ACC. Means it is possible that from MDR, data is sent, if this is an instruction, it will be transferred to CIR, and if this is a data item, it will be transferred to ACC. Now, this is the execution of instruction number 1. Then there will be execution of instruction number 2. PC will transfer this address to MAR. From this address, data will be fetched from this address and loaded to MDR, that is ADD6. From address 6, this is an instruction, so this data will be transferred to CIR to be decoded, ADD6. After decoding this, PC will be incremented by 1, means PC will be 3, and the address part of this instruction will be transferred to MAR, means here you will transfer the address part of the instruction. Then this address part of the instruction will be transferred to MAR. Then it will go to location number 6 and fetch the data from there into MDR, that is 8. And as it is a data item, it will be transferred to accumulator 8. Right? Now, the instruction was add 6, means we need to add the content 6. So ACC will send this data to ALU. ALU will perform calculation on 12 and 8. So there will be 20. This 20 will be stored in ACC. After this, the instruction number 3 will be executed. The instruction number 3 was store 7. So PC will transfer the address of this instruction to MAR. MAR will go to address 3 and fetch the instruction from there to MDR. From MDR, it will be sent to CIR to be decoded. PC will be incremented by 1, that it will be 4. Address part of the instruction will be transferred to here, and then the data from ACC will be loaded to MDR, and from MDR it will be sent to location number 7. Right? Dekhe beta, what is going on? Firstly, PC contains the address. This address is transferred from PC to MAR, and MAR go to this address and fetch the data to MDR. From MDR, this data is sent to CIR. From CIR, it is decoded. After decoding, the address part of instruction is loaded to MAR, and PC is incremented by 1. PC become PC plus 1. And this will be the next instruction. This is the way a fetch execute cycle work. Right, beta? Now, there will be end of the session. So after after some minutes, the session will expire and we need to rejoin it. Right, beta? देखें how fetch execute cycle is going on. In fetch execute cycle, suppose this is your memory. In memory unit, you have these are the memory address, and these are the content. There are two type of content. Some are instructions. Instructions are needs to be decoded. Some are data. They needs to be calculated. What is going on? Our instruction number 1 is load 5. PC will contain the address of next instruction. Now 1 is next instruction. PC will transfer this address to MAR. MAR will load this address to address bus and go to location number 5. 1. Fetch the data from there into MDR. From MDR, it sends to CIR. CIR decodes the instruction. For decoding, CIR sends this instruction to decoder. Decoder will decode the instruction. After decoding the instruction, the address part of the instruction is transferred to MAR and PC is incremented by 1. Then it will go to the location number 5 and fetch the instruction from this location into, it will go to location number 5 and fetch the data from this location into MDR. MDR will, this is a data item, so it will be transferred to accumulator so as ALU can calculate it. When 12 are loaded in accumulator, it means our instruction number 1 has been executed. After executing the instruction number 1, the PC will transfer the address to MAR. Now the beginning of the second instruction. Now it will go to location number 2. Now it will go to the location number 2 and fetch the instruction from location number 2 into MDR. It will go to location number 2 and fetch the instruction from there to MDR. MDR will send this data to CIR. CIR will send this data to decoder. Decoder will decode the data. After decoding the data, the address part will be transferred to MAR and PC is incremented by 1. 2 plus 1 become 3. Now it will go to the location number 6 and from this location it fetches the data to MDR. As it is a data item, so it is needed to be calculated. For calculation, it will be transferred to accumulator. Accumulator will send 12 and 8 to ALU. ALU will perform this calculation. This is ALU, so 12 plus 8 will become 20 and 20 will be stored in accumulator. After adding 12 and 8, the instruction number 2 is completed. Now this is the turn of instruction number 3. For executing instruction number 3, what will be happen? It will transfer no execution of instruction number 3. This address will be transferred to MAR from PC. This address will be loaded to address bus, and or instruction from this address will be transferred to MDR. As it is an instruction, so MDR will send this instruction to CIR. CIR will send this instruction to decoder. Decoder will decode the instruction. When decoder decodes the instruction, the address part of the instruction will be transferred to MAR, and PC will be incremented by 1 and stored in PC. Now, it will go to the address in this instruction. So the data from ACC will be transferred to MDR, and from MDR it will be sent to location number 7. So this is the complete fetch, decode, execute cycle. In this cycle, firstly we fetch the instruction, then this instruction is decoded, this instruction is executed, and then the result of instruction is after instruction is fetched. And remember, during fetch execute cycle, if an interrupt is generated by any device, store this instruction cycle into interrupt handler. Firstly, deal with the interrupt. After dealing with it resumes the instruction from and complete the fetch execute cycle. Remember, whenever an interrupt is generated by any device, interrupt may be generated by printer, interrupt may be generated by software like antivirus has scanned a virus. Interrupt may be generated by a user, like user has pressed Control Alter and break. Whenever an interrupt is generated, PC will stop the execution of fetch execute cycle, store the fetch execute cycle in interrupt handler. Then after dealing with the interrupt, PC resume the fetch execute cycle from interrupt handler.